So the instructions are factor completely. So if you remember your little flow chart handout that you got, your first step in factoring completely is to take out a common factor, meaning it has to be in common with everything. What do you have in common with everything here? You have a 3, which means you're going to divide everything by that 3. Okay. The factoring then, you leave the 3 on the outside. Now this begins with a 1, meaning the number in front of my variable squared is a 1. When it's like that, all you have to consider are the factors of the last number, and then you've got your unfoiling or your factoring. So I am going to look for factors of 15 that add to give me 8. They need to multiply to give me positive 15 and add to give me 8. Remember, you can just list your factors over here, and I just go down. 1 times what equals 15? 15. 2, that doesn't go into 15. Get to 3. 3 goes into 15. And then you're going to start repeating. 4 doesn't go into 15, but I've already listed 5, so I'm done. Those are my only options. The ones that add up to give me 8 are 3 and 5. I need them to be both positive. I know that because I need to multiply to get a positive 15, which means they're the same sign, and I need to add to get a positive 8. So I'm going to add both of those, which means I'm done. I can just list those as my groups. Don't forget your common factor, and then you're going to have A, and I have a plus 3, and I have an A and a plus 5. So you might have special cases on this quiz. When you see 9, 24, and 16, and you recognize that you do not have anything in common, multiplying across, you're actually going to get the same thing if you recognize that you have a special case, but life is going to be much easier if you recognize that you have a special case. So the first thing you want to do is, do I have a common factor? I do not. The next thing I want to do is it possible that I have a special case? So we are going to look at the first and last term to start. Is this a perfect square? Does it have a perfect square root? Well, yes, 9 has a perfect square root, and v squared will always have a perfect square root. That's just v. Then I'm going to look at my last term, 16. Is that a perfect square? Yes, it is. It is 4. So then I'm going to check my middle term. My middle term has to meet the requirements that it is 2 times my first term times my last term. So 2 times 3 times 4 times v is 24v, which is exactly what I needed for this to be a special case. Now that I know it's a special case, I can go straight to my factoring. It's going to be this square root of the first one, the square root of the last one. And when it's a trinomial like this, the special case is I'm going to use whatever was there, that's a plus, and it is the whole thing squared. It is the whole thing squared. If you did 3v plus 4 times 3v plus 4 and you FOILed it out, you would get 9v squared plus 24v plus 16. That is a special case. All right, let's look at number 12. My first step is to do what? To look for a common factor. 64, 64, 24, and 24 do have a common factor. What is it? 8 goes into all of it. So the first thing I'm going to do is I'm going to take out that 8. I have 8p cubed plus 8p squared minus 3p minus 3. I have 4 terms. My rule and my process to factoring 4 terms is to factor by grouping. So I am going to group my first 2, and then I'm going to go behind that middle sign and group behind and do the last 2. Here's the thing. If the sign that is in between it is a negative, then I am saying that I have factored out a negative, which means this last guy needs to change signs. Anytime the sign in between your 2 groups is minus, you need to change the very last one. Whatever he is, do the opposite. All right? Then we're going to factor each of these groups with just a common factor. So leave your 8 here. You're going to look at just this group and figure out what your common factor is. My common factor is 8p 8p squared. Remember, you use your lowest of your exponents. What do you have left? Well, 8 divided by 8 is 1. I took out 2 of my 3 p's. I have just a p. Then plus 8p squared divided by 8p squared. Anything divided by itself is just 1. Right? Then I have a minus, and I look at this next group, and I look and see what is in common. Here I have a 3 in common. Remember, if you don't have anything in common with that second group, you list a 1, right? So if I hadn't had anything in common, you still want to write a 1. But this has a 3 in common, so we're going to take it out. 3p divided by 3 is just p. 3 divided by 3 is just 1. My final step here, if you took out a common factor at the beginning, that's part of your answer, 8. Then I'm going to look at the group that I have in common. Then I'm going to look at what is left over, which makes up my second group. So anytime you see two terms, it's only one of two options. Either you just have a common factor and that's all you can do is take that out, right? Or you have another special case. The other special case that you have is subtraction, always the difference, always subtraction of two perfect squares. So in this case, you're looking for two perfect squares that are being subtracted. And the factoring for that is always going to be the square root of each with a plus or minus. So here's the thing. If you have a special case trinomial, he actually becomes 1, the whole thing squared. If you have a special case binomial, just 2, then he becomes 2 groups, plus and minus. So I'm going to look at this. Obviously, there's no common factor between x squared and 16y squared, but I do have perfect squares. X squared does have a perfect square root. 16y squared does have a perfect square root. When that happens, and it is subtraction, I'm going to list those two terms with a plus or minus. So my final answer here for this factoring will be x plus 4y, x minus 4y. And if you were to FOIL that to check it, you would see your middle term cancels out. All right? So we get to ones that are a little more complicated. Again, if you see one like this, your first thought is, can I take anything out? Always want to look for something in common first. So we're going to look between the 6, the 45, and the 75, and we're going to say I can take a 3 out. Then we're going to look at our variables, x cubed, x squared, x. They can all give me one of those x's. So 3x is going to be my common factor here. And then I'm going to divide everything. 6 divided by 3 is 2. I took one of those x's. 45 divided by 3 is 15. I took one of those x's. 75 divided by 3 is 25, and I took that x. All right, so this trinomial needs to be factored. I'm not done. I need to look at this and say, how do I factor this? It's not a special case because 2 does not have a perfect square root. So I'm going to use what we call the rainbow method. So on your handout, it's called the rainbow method. I'm going to multiply the 2 and the 25. So 2 times 25 is 50. I want a positive 50, which means I either want a positive positive or a negative negative. I'm going to look at that 15 and see they're both positive. I need factors that multiply to give me 50 and add to give me 15. What two numbers multiply to give me 50 and add to give me 15? 5 and 10. All right. So I'm always going to leave that common factor out on the outside. That's going to be part of my answer. This is the case where I rewrite the middle term. Leave the first term alone. I'm going to rewrite this middle term using those two factors that I just found. So I'm going to say plus 5x plus 10x. All I did was break up the 15 to the 5 and the 10. All right? Then you're going to leave that 25 alone. All right? How do I factor when I have 4 terms? What's my method for factoring? Factor by grouping. We've already done it, so we're going to do it again. Again, that 3x is going to hang out here. He is part of my answer. I'm going to look at the 2x squared plus the 5x. What do those have in common? Just a variable, right? So I'm left with 2x plus 5. Don't forget that plus sign. I'm going to look at the 10 and the 25. What do those have in common? And then I have 2x plus 5. And then to get to my final answer, you're going to list that 3x. Don't forget that. You're going to list the group that they have in common. And your final group will be what is left over. So remember, my first rule is that it has to be in standard form. X squared x constant equal to 0. If that is not true, you need to move things across the equal sign and reorder it so that it is x squared x constant and then equals 0. Always need to be in standard form before you start factoring, okay? So this guy is in standard form. This is actually a nice, beautiful factoring because it has a 1 up front. I want 2 numbers that will multiply to give me a negative 24 and will add to give me a positive 2. So I'm going to look at my factors of negative 24. That means one is positive and one is negative. And so yes, I'm going to say, well, negative 4 and positive 6. If I multiply those two, I get negative 24. If I add them, I get positive 2. And I've gone straight to my factoring for this one. So I'm ready. X, and I'm going to use a minus 4. X, and I'm going to use a plus 6. And that equals 0. Because I'm solving, I go one more step from here. I'm going to take that group. I'm going to set it equal to 0. And I'm going to solve. Add 4 over. I'm going to take that next group. I'm going to set it equal to 0 and solve. Subtract 6. So solving by factoring just takes that factoring one more step. Each factor is equal to 0. The difference here is this is not in standard form. I have to have everything on one side, a 0 on the right in order. So for this one, what I would do before I ever started, and I would move this over across the equal sign. You always want your leading guy to be positive. So my mx squared, or my m squared, I moved the 2m over. He needs to come next. He was positive on the right. It's going to be a minus 2m here. Then I have minus 35 equal to 0. Now I'm ready to do the process that I just did. Factors of 35 that give me a 2. And I'm ready to go. Okay, so that's the only difference in what was handed to you up front and what you need to do here. So this is already in standard form. It is already equal to 0. But this is not the factoring where you can just look at your last term. This is one where I'm going to do that rainbow method across, right? And so I am going to take the first number, 7. I'm going to multiply it by the last number, 4, and I will get 28. All right. Now I'm looking for factors of 28 that add up to give me 11, which happens to be the same two numbers I just multiplied together. But you would list them all out. You would get to 7 and 4. I need to multiply to get a positive and add to get a positive. So it's going to look like that. Remember, this is the case where I leave the first one alone. I break up that middle term to those terms that I just found. So I'm going to break that up to 7r and 4r. And then I'm going to leave that last term alone. And now I have successfully gotten a 4 term. How do I factor this? The same way I have factored 4 terms all along. I'm going to factor by grouping. Same rules apply. If I had grouped behind a minus, I would have changed my signs. All those rules still apply. Take out your common factor. What is left over? Take out your common factor. What is left over? Get your groups. So I have the group in common. I have the group that's made up of my leftovers, and I have successfully factored it. I'm not done. I am solving here. I need to go one more step, and I need to set each of those factors equal to 0. So I'm going to set the r plus 1 equal to 0 and the 7r plus 4 equal to 0. And then it's usually pretty simple solving. Subtract your 1, r could equal -1. Subtract 4 and divide by 7. R could also equal -4/7. Once again, not in standard form because I have a number on the right side. Once again, just like we did earlier, I need to move it to standard form before I ever start, which means I need to take this -7 and move it over. You are going to combine it with its like term. It will become a +7 on this side, so I'm going to combine that with the -15. So I have 3m squared minus 23m, and now I have a -8 equals 0. That is standard form. Now I can do my rainbow method, multiply across, break it into 4 terms, factor by grouping, okay? So once again, 3 times 8, 24. 1 and 24 are going to be your factors. You can break it up and you can factor that, okay? But you have to have it in standard form before you start solving for any of these. So in this case, I gave you the answers. I want you to give me the polynomial. So I am telling you x equals 2. X equals -4/3. I'm telling you that. I want you to give me the polynomial. All right? So remember, think standard form. I actually want all of my numbers and variables on one side, and I want a 0 on the right side. So I'm going to move this over. If it's just a whole number like this, an integer, it's really just going to be the opposite. If it's a +2, it's going to be x minus 2 equals 0. If it's a fraction, you're going to multiply both sides by that denominator. So the denominator becomes your coefficient. And the numerator is what's being added or subtracted. So we're going to move that numerator over. So those are the 2 pieces that I would have here. You could have 3 pieces, you could have 4 pieces, it doesn't matter. But in this case, I have 2. If I want the polynomial, I have to take these 2 groups, x minus 2, 3x minus 4, plus 4, and I'm working the other direction. I'm trying to work back. So instead of factoring, I have been handed the answers. I got the factors. Now I want to get the polynomial, and we just do that with foiling. Just multiply. So I'm going to multiply first terms, x times 3x, x times 4, -2 times 3x, -2 times 4. Obviously, I'm going to combine any like terms. And then I have my polynomial.